with out there.
But this idea that reality is an illusion is not a new concept. Hinduism, Buddhism, and Sikhism all talk about Maya, or life as an illusion. Mipam Rinpoche says that the real sky is knowing that samsara, the physical world, is merely an illusory display. The Kabbalah says that the first aspect of God is all that there really exists. All else is an illusion. And A Course in Miracles puts it this way: in any state apart from heaven, life is illusion. Outside of heaven, only the conflict of illusion stands, senseless, impossible, and beyond all reason. Illusions are but forms. Their content is never true. What quantum physics has done is first scientifically confirmed what many other people have said about reality being an illusion, and secondly, discovered what reality actually is: a holographic picture that only looks and feels real to those inside it. You could actually call this physical reality we live in a holographic 3D total immersion movie. Here's Woody Allen's version of a total immersion movie. And let me set this up for you. Which brings us to the question, exactly how is this holographic 3D total immersion movie created for us to experience as physical reality? Just in the last couple of years, we have discovered the answer to that question through some very amazing brain research. Dr. Karl Pribram has had a long and illustrious career. Born in Austria in 1919, Pribram is both a neurosurgeon and a neurophysiologist who spent many years trying to find out where memories are stored in the brain. The problem was that in the 1920s, a brain scientist by the name of Carl Lashley had found that no matter what portion of a rat's brain he removed, he was unable to eradicate its memory of how to perform complex tasks it had learned prior to surgery. So Pribram set out to solve the mystery of memory storage that seemed independent of brain cells, called neurons. But it wasn't until Pribram met David Bohm, one of the pioneers in quantum physics, that he found his answer. Here's how Michael Talbot describes it in his book, The Holographic Universe. Bohm helped establish the foundation for Pribram's theory that the brain operates in a manner similar to a hologram, in accordance with quantum mathematical principles and the characteristics of wave patterns. Technically, Talbot continues, Pribram believes memories are encoded not in neurons or small groupings of neurons, but in patterns of nerve impulses that crisscross the entire brain in the same way that patterns of laser light interference crisscross the entire area of a piece of film containing a holographic image. In other words, Pribram believes the brain is itself a hologram. Just as a hologram functions as a sort of lens, a translating device able to convert an apparently meaningless blur of frequencies into a coherent image, Pribram believes the brain also comprises a lens and uses holographic principles to mathematically convert the frequencies it receives through the senses into the inner world of our perceptions. In short, Pribram believes our brains mathematically construct hard reality by relying on input from a frequency domain. That's a very important sentence you will hear several times. Our brains mathematically construct hard reality by relying on input from a frequency domain. Let's translate all of this into simple English. According to Karl Pribram, and the results of many scientific experiments, some of which we will discuss in a minute, the human brain itself is a hologram. Its function is to receive holographic wave frequencies from a frequency domain, what we are calling the field, and translate them into the particular physical universe we see out there. Particular meaning made of particles in this case. Again, from Pribram, our brains mathematically construct hard reality by relying on input from a frequency domain. Or, our brains construct our holographic physical reality after receiving and based on wave frequencies from the field. You may have heard of another famous physicist, Nikola Tesla. He also said, "My brain is only a receiver." In the universe, there is a core from which we obtain knowledge, strength, inspiration. I have not penetrated into the secrets of this core, but I know that it exists. Think about a radio or TV set, which convert wave frequencies we cannot see into sounds we can hear and images we can see. Many scientific experiments have now proven that in the same way, the human brain receives wave frequencies downloaded to it from the field, and then converts those wave frequencies into our holographic physical reality. We're going to take a look at some of those scientific experiments and watch and listen to some of the experts involved. Next, Dr. Stuart Hameroff from the University of Arizona is going to describe a very famous experiment done by Dr. Benjamin Libet in the late 1970s.
In the late 1970s, a neurophysiologist at University of California, San Francisco, named Ben Libet did some very famous experiments. What Libet did was study patients who were having neurosurgery on their brains, with their brains exposed, while they were awake. They were given a local anesthetic to numb the area of the skull and scalp to access their brains. And they were awake, and Ben would talk to these people. So, for example, what he did was he would stimulate their little finger and look at the part of the sensory cortex on the opposite side that was related to that, record from it electrically, and ask the patient when he or she felt the stimulus on the little finger. And he would also stimulate at that particular area of cortex.
Let's make sure you understand the setup. A patient was on the operating table, fully awake, but with their skull and scalp anesthetized, and the skull was cut away so that their brain is exposed. Dr. Libet would stimulate their little finger on one hand, maybe a pinprick or needle stick, and the patient was supposed to tell Libet as soon as they felt the stimulus. Then Libet would directly stimulate the part of the brain associated with that same little finger and ask the patient when they felt that.
Now, what you would think would be that if you stimulate the little finger, it takes a finite period of time to get to the opposite side of the cortex, so the patient would report it a fraction of a second later after the stimulus. And when you stimulate it directly, the patient would report it immediately. He found just the opposite. When you stimulated the little finger, the patient felt it immediately, and when he stimulated directly in the cortex, there was a delay.
The brain is actually where we feel things. So when you stick the little finger with a needle, that sensation has to travel to the brain before it is felt. But if you stimulate the brain directly, you should feel the stick immediately in your little finger because the sensation is already in the brain. But, contrary to all expectations and logic, the patients felt the needle stick on their little fingers immediately, and it took time before they felt the stimulus directly to the brain. Libet was flabbergasted. He tried to find an explanation, as did many other scientists, and the prevailing theory became that time can travel backwards. It's called the time reversal theory. or subjective backward referral, or antedating. However, after trying to prove this and failing, Libet himself later said there appeared to be no neural mechanism that could be viewed as directly mediating or accounting for the subjective sensory referrals backward in time. In other words, there is no evidence in the brain for time reversal as the explanation for this phenomenon. Just put that information to the side for a moment, and let's go on to the next experiment.
So the experiment that I developed to look at this is we wire you up typically to look at skin conductance, but also heart rate and other parameters. You will sit in front of a computer screen and you press a button, and you know that 5 seconds later you're going to see a picture. It could be a very calm picture, or it might be a very emotional picture. And it's randomly selected by the computer immediately before it's shown. So when you press the button, the future is not yet determined. So you need real precognition in order to be able to jump into the future and get it somehow. So since we're looking at your physiology, we know what happens to physiology after you see an emotional image. And we know what happens after you see a calm image. The question is, does that future experience leak into your present? Does it happen before you see the picture? And through this experiment, you can see what happens. Electrical activity of the heart, EKG. This is photoplethysmograph, which is the amount of blood in the fingertip. And respiration, breathing in, breathing out. Press the button, well, what happens to physiology? Well, if it starts rising before the image appears, it may suggest that you're about to get an emotional picture. And if it stays calm, it suggests maybe you're going to get a calm picture. So we've done this kind of experiment for several hundred people, and colleagues have run this experiment as well, and as it turns out, that is exactly what you see. People become aroused before randomly selected pictures in the future that happen to be emotional, and they remain calm before randomly selected pictures that are calm. This has been seen in heart rate changes, in skin conductance, in the brain, and basically systemically throughout the body.
The only conclusion to this experiment that makes any sense is that the brain knows what picture the computer is going to choose and display before the person is aware of it. Indeed, before the computer has even chosen which picture to display. And the body is responding accordingly. Basically, what science is discovering is that our brains seem to know what's going to happen before we do.
There have been some studies which have shown that when people are beginning to move a hand or beginning to say something, that there's actually activity in the brain in certain nerve cells of the brain, even before they become consciously aware of what they're trying to do.
That's worth repeating. There have been some studies that have shown that when people are beginning to move a hand or beginning to say something, that there's actually activity in the brain or certain nerve cells of the brain even before they become consciously aware of what they were trying to do. As strange as that may sound, it is being proven time and time again with the latest research and technology. Here's a BBC documentary from June 2010 that confirms